let's see this example. Represent the number 117 base 10 in IEEE 754 single and double precision formats. So we have to write what does this number, when we represent this number in single and double precision, how does it look like. So first let's try to convert this number into binary and then get it into implicit normalization form so that we can represent it in both the forms, right? So 117 is going to be 1110101. This is the representation for 117, right? But according to implicit normalization, you have to take the more significant 1, and to the right of it you should get the radix point, which means I should put radix point here, right? If I put radix point here, I've actually decreased the value, right? Therefore increase the value. So you have to multiply with 2 power positive number. So what is it? 1 2 3 4 5 6. If I multiply with 2 power 6, it is again going to be the same number. Got it? Therefore exponent is going to be 6 and mantissa is going to be this one. So mantissa is going to be same in both the formats, but whatever exponent is there, we have to bias it, right, in both the formats. So in one format, let's talk about single precision. In single precision, we have to, if we talk about single precision, then the bias is going to be 127. Therefore E plus bias that we have to save in the format is going to be E is 6 plus 127. So this is going to be 133, right? And in the other one, this is in the single precision, right? Okay, let's finish off single precision first. In single precision, if we have to represent this, we know that first one bit is going to be sign, and since it is a positive number, the first bit is going to be 0, and the remaining 8 bits is going to be exponent, which is biased, which means I need to save 133. So 133 in 8 bits, right? So 1 followed by 1 2 3 4 followed by 101. So this is 128 followed by 5. 128 plus 5 is going to be 133. Got it? So 1 2 3 4 5 6 7 8. So this is sign bit and this is the exponent bit, exponent part. And what about the mantissa? So the mantissa is going to be this entire part. So 1 1 0 1 and then 0 1, so on, all zeros. How many zeros? 23. So 23 here. So totally 23 bits should be there, including zeros. And what about this? It is going to be 8 and it is going to be 1. So if you count it, is going to be 32-bit representation, right? Now what about double precision? In double precision, you have to be careful about bias. Bias is not 127, it is 1023 is the bias, and therefore exponent plus bias is going to be 6 plus 1023, which is going to be 1029, right? So how to represent this? Again, in double precision, one bit is going to be for sign, so 0, that is 1 bit, sign is 0, that is why, and remaining 11 bits are going to be for exponent. So now in these 11 bits I have to represent 1029, right? So it is going to be 1024 plus 5. So first bit is 1025 and then 1 2 3 4 5, so total is 6. So I have to put 8, right? So 1 2 3 4 5 6 7 8 and then 101. So this is completely 11 bits, and all these 11 bits are going to represent exponent. Okay, exponent is going to be 11 bits and the remaining part is going to be mantissa. So how many bits are going to be mantissa? 52 bits have to be in mantissa, out of which the starting bits are going to be 1 1 0 1 0 1, and all of the remaining bits are going to be zeros, right? So how many bits should it totally be? 52. Got it? So this is the double precision representation for this number, right? So single precision and double precision. Okay, fine.
Hi,
if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.